In this video we're going to look at a special type of sequence known as an arithmetic sequence or an arithmetic progression. On her first birthday, Uncle Nick plans to give his young niece Isla £50 and plans to increase the present each year by £10 until she reaches her 18th birthday. And we're asked how much will Isla receive from Uncle Nick on her 15th birthday and how much will Isla have received altogether from Uncle Nick by the time she has received her final present. Well, on her first birthday she receives £50. On her second birthday she'll receive £50 plus 10, in other words £60. On her third birthday she'll receive 50 plus 10 plus 10, in other words £70. And on her 15th birthday Isla will receive the £50 plus 14 increases, each of £10. So that gives me £190 for the 15th birthday present. In general then, Nick will give Isla a present of PN pounds for her nth birthday, where PN is £50 plus n minus 1 jumps of £10. In other words, we've got 50 plus n minus 1 times 10, which simplifies to 40 plus 10n. So we've got an expression for the amount that Nick will give Isla as a present for her nth birthday, and that amount is 40 plus 10n. The sequence that we've got here, which goes 50, 60, 70, all the way up to £220, is an example of an arithmetic sequence. We can use the fact that we know that Isla's present on her nth birthday is going to be given by 40 plus 10n, and our knowledge of sigma notation to calculate how much money she will receive by her 18th birthday. So on our calculator, if we simply work out the sum between 1 and 18 of 40 plus 10n, we'll obtain the answer of £2,430. Now there is a much easier way of finding the sum of an arithmetic progression, and we'll discover that in the next video. Sequences like 40, 50, 60, 70, etc., which were the size of Isla's presents, in which each term is obtained by adding a constant number to the previous term, are called arithmetic sequences or arithmetic progressions. The number which is added each time is called the common difference of the sequence or the progression. Provided we know the first term and the common difference of an arithmetic progression, then it's possible to write down as many terms of the sequence as we wish. So for example, if we have an arithmetic progression whose first term is 11 and whose common difference is 1.7, it's fairly easy to write down the first 5 terms of the sequence. We've got 11 plus 1.7, which is 12.7, 12.7 plus 1.7, which is 14.4, 14.4 plus 1.7, which is 16.1, and then 16.1 plus 1.7, which is 17.8. Now notice that 12.7 is the same thing as 11 plus 1 lot of 1.7. That 14.4 is the same thing as 11 plus 2 lots of 1.7. That 16.1 is the same thing as 11 plus 3 lots of 1.7. And that 17.8 is the same thing as 11 plus 4 lots of 1.7. This enables us to write down that the 80th term of the sequence is going to be 11 plus then 79 jumps of 1.7. So we've got the 80th term is 11 plus 79 times 1.7, so that will be 145.3. Similarly, the nth term is going to be the first term, which is 11, plus n minus 1 jumps, of 1.7. So we can say the nth term is 11 plus n minus 1 times by 1.7, which simplifies to 1.7n plus 9.3. And if we generalize this, so we have a arithmetic sequence or an arithmetic progression whose first term is a and whose common difference is d, then the first 5 terms of this sequence are going to be a plus d, a plus 2d, a plus 3d, a plus 4d, etc. The 80th term of this sequence is going to be the first term plus 79 jumps of d, so that's a plus 79d. And the nth term of the sequence is going to be the first term a plus n minus 1 jumps of d, so that gives me a plus n minus 1d. For an arithmetic sequence with first term a and common difference d, we have the nth term is given by the expression a plus n minus 1 times d. How many terms are there in the arithmetic sequence that goes 3, 5.8, 8.6 and ends up at 339? Well, if we say suppose there are n terms, we know that 339 is the nth term, and the nth term is 3 plus n minus 1 times by 2.8, because the sequence has a first term of 3 and a common difference of 2.8. So we've got 339 must equal 3 plus n minus 1 times 2.8. In other words, subtract 3 from each side, we've got 336 is equal to n minus 1 times 2.8, or 120 equals n minus 1, so n must be 121. An arithmetic progression has 5th term 52.7 and 12th term 33.8. We've got to find the first 3 terms of the sequence and determine how many terms of this sequence are positive. Well, if we suppose that the first term is a and the common difference is d, then the 5th term is a plus 4d, so we must have a plus 4d equals 52.7. The 12th term will be a plus 11d, so we've got 33.8 must equal a plus 11d. So we've now got a pair of simultaneous equations for a and d. Solving those gives me a equals 63.5 and d equals minus 2.7. The first term is 63.5. The second term is going to be 63.5 plus d, in other words 63.5 take away 2.7, which is 60.8, and the third term is going to be 63.5 take away 2 lots of 2.7, which is 58.1. So we can see here we've got a common difference of minus 2.7. We want to find out how many terms of this sequence are going to be positive. So the nth term is positive if the expression for the nth term is greater than 0. The expression for the nth term is a plus n minus 1 times d. So in this case, the nth term is given by 63.5 plus n minus 1 times minus 2.7. And we want that to be bigger than 0. Simplifying, we've got 63.5 minus 2.7n, add 2.7 has got to be greater than 0. In other words, 66.2 has got to be bigger than 2.7n. Dividing each side by 2.7 gives me n must be smaller than 24.52. So that's telling me that the 24 terms in this arithmetic progression will be positive, and any terms after the 24th term will be negative. So that concludes our first look at arithmetic sequences.